introductions. I co-founded a startup, Lumio.id. What is it? Like, the purpose of Lumio is to make digital signage to be smart, like to deliver dynamic contents, and also to measure people that check out the digital signage. So there's Android part of it. I mean the cloud part. There's the cloud part too. But I'm just talking about what relates to me because I'm one of the Google developer experts for Android. There's two from Indonesia. So I work a lot on the Android part, on the player side, and it works. We talk to the sensors, and also we use ML to make the display smarter. So this is just an example. So that's one thing powers that big screen over there, and this is my partner. I guess you see that it's so small compared to the screen. So why? I guess today we have two talks about machine learning, right? Why is that? Because I guess Sundar, I guess this past few years of Google IP, there's more and more machine learning stuff, machine learning sessions, because he said that there is a shift from mobile first, like I guess 3 years ago, 4 years ago, probably we talked a lot about mobiles, Androids, but nowadays, I guess there's a shift going to machine learning, right? Because that really make a difference in your app. So what is machine learning? It's a subset of artificial intelligence, and if you see the bold part, it's ability to learn with data. So it gives computers ability to learn with data without being explicitly programmed. I think Cass already shared this activity detector, right? So for me, I want to have a pragmatic approach to machine learning. So we're not going to talk about like the theory behind machine learning, all the maths, like the deep stuff, but how we can use it, how we can use machine learning practically as a mobile developers. So, but I'm still going to share a little bit like the basics of machine learning, just like what Cass already shared. So explicitly programmed means that you have like a lot of if and else statement, right? I mean, as a programmer, I guess we live seeing that if and else a lot, right, on the screen. So in traditional programming, you set the rules, like if this, then that. And you give the data, and the data will go through that rules and as a program, and it will give out the answers. So this is a sample from the activity detector that I think Ken already shared the pictures. So if speed is the data, the input, right? And rules is the conditional. So if the speed is less than 12, then what answer you should give? Then it's running. Or if it's less than 20, then it's biking. But it's true that not everything that can be done, it can be done with explicit programming, right? Because like detecting cat or dogs, or even people with other people, facial recognitions, and different things like that, it becomes harder and harder with traditional programming. That's why we need machine learning. So here, we see that machine learning, you give all the answers first. So instead of giving up the input, you give the right answers, like different the data, and also the data. So for example, if it's in images, for the machine, the model to classify what object is what, then the answers will be the label. it will be skirts, and the data is the image. And the machine learning will, by doing that, we're creating a model, right? So that every time we give an input, then it will give us the answer. The predictions, I guess, because everything in machine learning is a prediction. So there is no 100% sure, but at least the predictions gets closer and closer to 100%, or to the correct answer. So I guess since this is a GDG event, right? So probably if we talk about machine learning, then we talk about TensorFlow. Because it's open source and it's, Google has a lot of development on TensorFlow. So mobile developers, what are we going to do with ML? So with ML, we can, machine learning as a mobile developers, if we integrate it into our apps, then we can deliver richer and smarter experience for the users, for our users. Even we can use ML to, since a lot of our apps probably will have user content, generate content, right? So instead of having a lot of manual filtering, manual moderations, then we can have machine learning on device even before they upload their content to be filtered there. But how to do an on-device machine learning in limited hardware resource like smartphones and microcomputers like what I'm doing in Vimeo, right? Because the processor unit is not as big as, if you do it in the cloud, right? You have unlimited resources. Even the CPU or the GPU is, you can have as much as powerful as you can. But on a phone or on microcomputers like Raspberry Pi, board similar to that, it's hard to have this at first. Have a machine learning doing real-time on-device machine learning on the device. It will be really, really slow. So if you talk about TensorFlow, before there's the light version, right? The real light. The model size is big. When we talk about mobile applications, the size matters, right? Because I think probably you guys already heard the presentations about the making application for a billion users. A lot of times in my country, Indonesia, I think it's also similar to India too, right? Like internet data is expensive, right? Not expensive, but it's not like unlimited, right? It's limited resources. But so that's why if you're doing this for mobile applications, you need to make sure that your models be small and that it's not using too much CPU power. Because if not, then it will be really, really slow. So that's why we need TensorFlow Lite. So what does TensorFlow Lite is doing to make the model smaller and less CPU intensive is that it uses 8-bit signed integer quantizations. So instead of float numbers for computation, they use signed integer, 8-bit signed integer. And also, it also does some pruning on the neural network so that it reduces all the unnecessary steps. So how does TF Lite architecture looks like? So here you can see that there's the model, the trained TensorFlow model, right? And we need to convert it. We need to use the TensorFlow Lite converter to convert it to TF Lite format. And once we got that, we have the interpreter running on the app that will use that model to predict the results. So here we can see that TensorFlow Lite works on embedded Linux, on Raspberry Pi, also on Android OS, and also microcontrollers. And we'll talk about MLKit soon after this. So one thing that's interesting is that since Oreo, Google released an API called Android Neural Net API. So the Android team makes that API so that we don't need to care what's as the implementer for the machine learning part. Doesn't need to know what kind of device it is, what kind does it has only CPU or it has a GPU or it has an NPU. So with the API, then it's transparent on the application data, right? So if we are on a Pixel, like Pixel 2 thing, then everything will run faster because it uses the Visual Form. So the steps we're going to do, like I'm going to do a walkthrough that for the model conversions. So when we have a TensorFlow model, we save it and then we pass it to the converter to convert it to TF-like format. And once we're done with that, we got the TF-like model. And I'll show you how to use it too. So first, before we get to into TF-like, here we see a simple case of ML. So this is from one of the collab, Hello ML, I think. Probably some of you already seen this, but I think this is really good for example for machine learning, especially for linear. This is something that's still linear, right? So it's still easy to grasp. So here we're doing temperature Celsius to Fahrenheit. So in traditional programming, we just do that and display it to the text field, right? In Android. I'm using Android as an example, right? Because Android expert. But iOS users should recognize this too. So with traditional learning, it's easy because you just put the input and then everything you'll get the result, right? With that formula. But with machine learning, you have the answers and the data and the answers. So you give the machine learning how to learn from that data and the answers. So instead of just giving the inputs for machine learning, you give the values, several values of the in Celsius, and also give out the result in Fahrenheit. So you pass it through and train your model, and it will generate the rules, right? And the rules will be correlations between the data and the answer. Okay, so this is some code that you can see. So we use TF-Keras, and we pass on the both side. You can see that we pass the Celsius and also the array of the answers in Fahrenheit. So once you train that, you got the model, and once you save the model, you just pass it through the TF-like converter, and it will write it into the file that was specified. And this is how you use it in your apps. Okay, this is Android examples, but should be pretty similar to the iOS version. So you load the model file. If you put it on the asset folder, then you use that, this asset openMD. And you pass it in the stream and then return it. Or then you use it here on the interpreter. Because when you look at the architecture, right, the TF-Lite needs to be run by the interpreter. And here you can see how we are using it. So once we have the interpreter running, we can just use the float array of Celsius. We can give out the Celsius value, and then you just run it and prepare the output, allocate the output storage, and then it will run. And you can get the result by using the output flow. So here you have to input to the model and run. Okay, so probably Celsius to Fahrenheit conversion is not that fun, right? You probably, I hope that you're not going to be like feeling like this dog, like boring but interesting. Tell me more. Case 2, image classifications. I think a lot of has a lot of samples, like really good samples on how cool is it to have ML, right? And to classify stuff. And what's the use cases. Here, we're just using it to identify flowers, different type of flowers, because you can also use that. And even what, I guess yesterday I was talking in another event, and I was saying that probably we should make an app to recognize local foods. Because like today, this morning, when I'm on the way here, I'm talking about Indore food. And I heard that from Yashu, where's Yashu? Said that Indore is famous for food, right? And you guys agree? But I'm the newcomer, so I don't know a lot of names and a lot of foods, so probably if you guys you make an app for it, I can download it next time I come here. So here we have rose, and this is sunflower, right? And if you see that app when it's running, it will give out the time it takes to predict, to give out the results, and it shows the predictions, how confident the computer detects that it's roses. So for example, that one is 0.71. So it's sure about that picture is a rose, but not quite 100% sure. But with the sunflower, it marks it as 1.00. So usually in mobile machine learning, you start with mobile net model, because it's already optimized for low power and low power computing, like devices such as mobile phones and also Raspberry Pi. So here you can see that mobile nets are small, low latency, low power models, and it can also run efficiently on mobile because it uses different convolution than the other one. Mobile nets trade off between latency, size, and accuracy. I mean, when we try to get size smaller and the latency also, so it's thick, usually the predictions, the accuracy is a little bit less than what it is. But usually it's pretty accurate already, so it's pretty similar. Like it's only like 1 or 2% lower in accuracy. But it's a trade-off that I think all mobile developers probably will think. And if you see this, for example, like if there's ResNet and exceptions, compared to mobile net, it's much faster for the inference. So here, if you want to create a model, usually you need to have the data, right? I think Cass also already gave a lot of videos on that. But here, yeah, you just put different pictures for different flowers. So you separate it into folders. But I think Cass already shows you how to upload it to the cloud and do the training there. But here, if you want to do it in your computer, you can also do that, as long as you know a little bit more Python. So here, you just pass it through the retrain have all the text file for the labels too. And once you get the model, you can test the result by using this command. So once you have that, you get the result. So for example, this picture, the daisy, it recognizes it as daisy, and the score is 0.99 out of 1. So that's pretty good, right? Pretty accurate. So case 3. So ML kit. This is much easier than compared to the case before this. Like, we don't need to create our own model. I mean, we can, but Google already provides this kit for us so that if we need ML to do some commonly used use case, then we can just directly use ML kit. And it's part of Firebase right now. So if you want to use it, you need to add Firebase dependencies to your app. So what can it do for ML kit? It can do vision, also language, natural language processing, APIs, and also custom. If you want to have a custom model, you can also use that. Because then for all the updates and everything will be done through the Firebase console, and you don't need to take care of how to update the models into your apps. Because like, models need to be updated, right? Like, the result is as good as how much training the model gets. So the more data you give to the model, then the more accurate the result will be. So what's the benefit of ML kit? It's already production ready for common use cases. So we already see that a lot of vision stuff and natural language processing stuff. And it's flexible because it can run on device, and if it's you can also run several stuff on the top. And it can also deploy custom model. Here, one of the things that we can do with the ML kit right out of the box is text recognition. So you can do this like what Google Translate has been doing, right? So you can overlay the text directly with translations. Because when you use ML kit, what you get from the image is that you get all the text with all the bounding boxes, so you know the positions of the text. And landmark detections. So if you're doing a travel app, or if you have a lot of user-generated content, you can use this so that you can tag the pictures automatically with the landmarks. And face detection. I think a lot of face detection apps. I think a lot of apps right now using face detections to do fun stuff, right? For example, this is my daughter. I think probably all of you knows, right? What filter is this? Which app can do this? I think a lot of apps now can do this. But if you need this on your app, you can do that with ML Kit. With the face recognition API, you will get those results, like all the coordinates, everything, so you know where, like, you can do whatever you want with the result. So, for example, here, some of the data that you can get is nose bridge, left eye, positions, and upper lip. So you get everything with this much data, and this is run on the device, right? A device, so it doesn't need to go through the top. And with this, you can do real-time stuff with that image or that video. Barcode scanning. So here we see that this is probably everybody already uses this. This is part of ML Kit 2. And image labeling. So when we get the image, we want to get the labels, just like the what we have in case 2, right? But it makes it much easier because with ML Kit, you can have a model or the pre-built model. So there's two. And how to use it is really, really easy. You just need to add these dependencies. So Firebase 4, I guess for sure, because it needs that. And then the second one is the ML model. That's to do the ML stuff. And here, we see that we just need to define the local model. You just need to give the name of the file, the model that you have locally. And for the cloud source, you can have this. But the difference is that you need to probably add this because, just like what I said before, as a mobile developers, we need to be a good citizen, right? Like, I guess we need to care for our user because our user uses their smartphone. It's not just for our app, but they have other apps or they have other needs too, right? So we need to conserve data. So here, we can force it so that it can update automatically, and then we can set that for the first, when it first loads, should it downloads, I guess you can give conditions. Just like if you have used Work Manager as part of Jetpack, you can give some conditions like that. So when you want, if you want the app to download the model only when it's connected to Wi-Fi, then you can also do that. So it doesn't take your 4G quota. So here you set whether you want to update and have conditions and initials. Probably for initials you want to just download it, but for updates you can just set it so that it's only running on Wi-Fi. So you can always improve your model on the run. So after you release your app, you can still update your model. So after this, you just need to let MLKit do its magic. So you just pass the image data into it as an input, and then you just get the result. You can process the result however you want. So, fun fact. Is this a dog or a girl? You'll see this. So what do you think? Probably you guys already know, right? It's a girl. But the fun thing is that when I try to search it on Google Photos for dog pictures, a lot of my daughter pictures come up on that search result. I mean, sometimes I think my daughter acts like a dog. But yeah, so with this example, we can see that, there's takeaways, right? Like, ML is not perfect, but the more you train it, you train the model, you give more data to it, the more accurate it will be. So, because machine learning deals with probabilities, right? Like when you see from the image classifications case, you see that it can give rows for 0.7, but then it thinks that it's a daisy for 0 point something. So nothing is for sure. But yeah, just the thing that you need to remember is that you need to train. If it's not accurate enough, if you test it out, if you have a custom model that you've been using on your apps and it's not accurate detecting some objects, probably you need to train it a little bit more. And it's good to be pragmatic in implementing machine learning because we as I guess the applicator, right, like the one that creates the mobile apps, we still have a lot of things to think about, like the business logics and everything. So if we just need something related to ML, we can use ML for some common usage, then we can just take something that's practical, like MLKit. And if you get the basic math and algebra, probably then it will help you to understand a little bit on certain things like when we're creating models, stuff like that. And then the more this is some of the resources that you can do. I think the code maps is really good for you to start with. I think it gives you the same, I guess it will give you detailed explanations on how machine learning works, and it will help you to get started. And there's a lot of other resources that are really good out there that I come up with here. So, are you guys ready to deliver richer and smarter experience to your app? That's good. So, I hope that next time I can use your app for detecting local foods, okay? So if one of you make that, then please contact me so I can download it and have a reason to come here again, right?